Hello and welcome back to Polytudes. In today's lesson we have got an absolute treat. This is a raindrop shader tutorial that's using triplanar mapping, so it's a bit of a two-in-one, which means this tutorial might be a little bit on the lengthy side, but we'll see how it goes. And so just quickly before we dive into it, I'll just run through just kind of what this shader is actually doing, so you can see whether or not you actually want to learn it, I guess. So I'll just have a little zoom in to begin with, because you might be watching this on mobile and you can't see anything that's happening and you just no idea what this tutorial is supposed to be about. But there are actually these rain splotches and rain streaks running down this vehicle. And just as a quick aside, I did get this vehicle model from Sketchfab from a user called Karol Miklas. Karol Miklas? I don't know. I'm not going to be able to pronounce that correctly. The link is in the description. This person has just an absolute insane amount of amazing vehicles. I recommend checking them out. It's some good quality stuff there. So you can see these rain streaks coming down the sides of this vehicle, on the glass and whatever else, but the top of this is actually, there's no streaks. It's just the rain splotches, so that's one thing we'll be taking into consideration. We don't want the streaks appearing everywhere, because that doesn't make any sense. And obviously with the triplanar mapping, if we were to rotate this bus or any asset around, the rain streaks are still going to always want to fall down. So before, that roof only had the splotches, but of course we turn it around, now it has the raindrops, the rain streaks going down it. And then the last thing to just quickly mention is the underside of this doesn't have any streaks or the splotches, so I've tried to keep it as quite reusable on as many assets as possible, so I don't need to keep making the same kind of shaders depending on the object. So this is intended to kind of be a quick little all-in-one solution for just general kind of rain effects. So anyway, this introduction has been going on for way too long, so let's just go ahead and get right into the tutorial. So, new scene, I've wiped all of the materials, and it's worth pointing out that because I did grab this model from Sketchfab, I will not be able to provide it on my Patreon, but everything else like the shader, texture, all of that stuff, freely available, and now I'm finished with the plug. So I'm just going to drop in a cube and a sphere. That will be, the things that we will focus on whilst we're making this shader, but I'll keep the vehicle in here just the company, and also it will help provide some different examples as we continue to build this thing up. Now the key ingredient to this shader is actually just this one little texture file here. If any of you have seen my previous rain tutorial, you know that we did all of that with the particle system, which is pretty cool, and I recommend checking it out. If I remember, that there will be a link somewhere in the top right or whatever. But for this one, no particle system, no cameras, render texture stuff. This is just all happening within a texture, and we're just putting some stuff in the red channel and in the green channel. This is just the bare basics, so we're just going to use 2 channels. And I'll quickly just sort of speed through my Photoshop process of just creating that. So I have a document here, I think it was a 512 by 512. And you'll notice over on the right, I have a layer 1 there, completely black, and then layer 2, I'm just filling it in with this this rain streak, which is just, white circle at the bottom, and then a white to transparent gradient going up. And then just duplicating that all around until, you're kind of happy with roughly where it is. I did put in way too many streaks here, and I ended up coming back off camera and just removing a few. And then when you're pretty much happy with how they are to begin with, what you can do is select all of your layers and just do, I think it's Control E, just to merge them all into one. And then you can use this offset filter. And since we know that this is a 512, we want to offset by 256 on the vertical. So now it will move, that whole layer 256 pixels down. So now we can actually put in some more rain streaks in the middle portion here. This will kind of help with the tiling, and then it will make it, a little bit less obvious. If we just had it as it was before, there would be, a very obvious gap in our texture as it scrolled down. And then when you're finished with that, you can just create a new document, make sure it's the same size, fill the first layer with black, and then we'll come over to our texture here that we've made, select everything and use the copy merged, and then just paste that into the red channel of our new texture. If you're using something else other than Photoshop, I'm not entirely sure what the pipeline is for this, but that's how you do it in Photoshop. And then lastly, we want to put something in our green channel, so we're going to just create a gradient here going from left to right, so it's just white to black. And same again, just copy all of that, put it in the green channel of our new document, and that's it, we're done. You can save this out and we can use it. Okay, so after 5 minutes, we are finally now ready to create a shader. So we're going to right click, create Amplify Surface Shader, and, you know, open it up, call it whatever you want. And we're going to begin by just putting down a texture 2D. And just to help with the more visual side of things, I'm just going to drag the rain texture into this texture sample so we can actually, you know, see what's happening within the editor. And because I always forget, I'm just going to save this out, right click on our shader and create a material from it, which will automatically propagate the correct material. And then just put this on all of our objects. And now if we go back into the shader here real quick, I'm just going to put on a animated panning onto our UVs. And the easiest way to do this is just with like multiplying a vector by a time node and sticking that into like an offset variable. But of course, if you use a vector 1, it's going to apply to both X and Y, which means it will basically animate our texture, like scrolling down on both the X and the Y. So it will be going horizontal as well as vertical. Obviously, we only want it to go vertically. So one quick way to solve this issue is if you get a vector 2 first and you multiply that by a vector 1. But it's important to note that in your vector 2, you have an X and a Y, so you want to leave your X blank because Y is going to be our up and down. So X will be 0, Y will be 1. And now, because we're multiplying that by vector 1, we are essentially only controlling, you know, the power of that Y value, because that's the one that is actually, you know, set to a value higher than 0. I know that sounds super nerdy and super boring, but it's kind of important to know, especially if you're new to shaders. But either way, once you have that, let me just show you what this does so we can all get a good understanding as to what's happening here. So, as expected, we just have this texture that's panning down, but of course if we were to grab these things and rotate them, the texture is not trying to always point down, because this is just using the object's UV. So, you know, you rotate the object, it's going to rotate the texture. That's one of the things we want to solve. We want to be able to mask out, or rather, you know, identify what is world up and world down. And we also need to create some world space UVs, and we're going to be doing the triplanar stuff. So we'll get started with that now, and we'll begin with the world masks, I guess, for want of a better term. But first, we do just need to wipe pretty much everything that we've just done, except for the texture. We'll keep that. That was just for demonstration purposes only. And as one other little demonstration, if I were to just grab a world normal node and stick it through an absolute node and then just plug that into the emission, you can see the result that we get here, and that we have our, you know, our red, our green, and our blue. And these are the world normals, and we're using the absolute node so that it actually projects on both sides. But the point here, of course, is, you know, whichever way you were to rotate these things around, it isn't going to change where those normals are pointing. You know, blue is always going to be at the front, X is always going to be at the side, and the green is always going to be at the top. And with the absolute, we also have the opposite of that. So, you know, back, front, left, right, up, down. That's enough for demonstrations now, though, I think. So let's actually just go ahead and start creating some stuff that we're not going to throw away. So we'll keep our world normal and the absolute, and we'll put it over here where we have some more space. And we'll just break this into components. And if you're using shader graph, I believe that's called a split. And as you can see here, we have the X, the Y, and the Z, and you can see the projection. So X, we have them on the sides, the Y is up and down, and the Z is the back and the front. Obviously we can't see both of those at the same time because one of them is behind the other, but you get the idea. So that pretty much sets up our entire masking. Like there's not much else we need to do for this, like we have the masks now. I realized that I might have skipped through that a little bit quickly, so these purple nodes that you see here, I placed those down just by hitting the R key. They're called registers, and it allows you to basically register an output here, and then we can use a get node somewhere else to reference back to this node. So it means you don't end up with this whole spaghetti shader stuff, and you can actually just have things like in nice compartmentalized areas, which is always neat and tidy. The only other thing to mention here is to name them something sensible, because you will be referencing back. So we have our X mask, Y mask, Z mask. Job done. And as part of keeping things neat and tidy, I'm just going to select all of these and hit the C key, so it will create a group here, and I'll just give this a name, and that is it. So let's grab our texture. It's already there, we might as well use it, and we'll begin the triplanar projection stuff, or the dual planar projection to be more precise, I suppose. And we're going to start with a vertex position node, and we're going to feed this through an object to world. I know here I'm using a world to object. that is a little boo-boo on my part. We actually do want the object to world because we want to keep this using world space UVs, but everything else is correct. Like, you do want to get this append node, and we'll plug this into, you know, the X and the Y will go into the X and the Y of the append. And the reason that we do this is because if you look at your movement axis, for example, you can see, you know, the X is the red arrow, Y is the green, and you can see, you know, the plane that it creates there is that front facing one. So by setting this up here, what we're actually doing is creating world space UVs for that front projection. I hope that makes sense. We do need to be able to control the tiling of this. So we'll create a multiply, and we'll just create a vector 2. And the reason we're going with a vector 2 for this is because I want to be able to control the X and the Y of our texture separately. This isn't anything to do with that thing that I was talking about earlier with the offsets. This is just like, I literally would like to stretch my texture at certain points. So, you know, I might want the X to be a higher value than the Y. And then we could just get a register node, and we'll just stick all of this end result into it. Oh, and of course, give your register node a sensible name. Now we do only want the red channel of our texture here, because obviously if we were to put in the RGBA, we would get both of those textures that we made, which is, you know, the streaks and the gradient. We only want to work with the streaks for now. So we'll come over here and we'll use a get, and we'll just get that last register that we made, which is the one for the streaks. We'll stick this in emission and we'll just have a look at this. And this is where I realized the mistake I've made with the object to world, world to object fiasco. So I do just fix that up real quick. And now you can see that when we rotate the object, the rain does not want to, you know, to rotate with the object itself. So the rain is always going to be pointing down, at least on the front axis here. Now we do have, of course, lots of problems. There's like this weird sort of streaking happening along the top and the side of the vehicle, and we will fix this stuff up. For now, let's just get the panning functionality back in, and so we'll actually use a panner this time, and we'll just multiply a time node by a vector 1, and, you know, you can call this the streak speed. It will be the speed of this raindrop basically falling down your mesh. And then you just want to put that into the time node of your panner, which means now your panner node, the speed function of this basically becomes the direction, so X direction and Y direction. And of course we want the Y because we want it to go vertically. So hammer 1 into there, and you can see already in the register node that we have on the right, this is panning down. There we are. So yeah, pretty cool. It's moving. We do still have those streaks issues, so let's go and clean those up now, I think. So we'll make a little bit more space. This time it'll be after our texture, but before the register, because obviously the register is, you know, the end, the output. We'll just get a lerp, and we want the A slot of this to actually be blank. So we'll put the R channel of our texture into the B slot, and then for the alpha, we're actually going to just get the Z mask, because if you remember from the example, you know, we were projecting this on the front, so we want the front mask, which is the Z. And so now if we go and take a look at it, you can see that the streaking, at least on the like a very top plane, has stopped. We still have some. If a mesh is sort of slightly not completely straight, you'll still get some of those streaks coming through. We can fix those later, but for the most part, you know, this is it's kind of cleaned up. It's not nearly as messy as it was before because we are using a mask to determine where the texture is shown. And in true developer fashion, we'll just leave those fixes and tweaks for later on. For now, we have our Z projection, so let's get working on the X. And so we want to copy a bunch of stuff here. We'll copy all of these nodes that come before the texture. We don't need to copy any of the time stuff we did or the vector 1 because obviously we want to reuse that. So once you've copied over those nodes, just place those vector 2s for the tiling in and the time vector 1 multiplied thing that we had. So that is going back into the panel. It's basically just, you know, it's a mirror image of what's happening underneath. Now, of course, our UVs for this are still on the Z. We want it to be on the X. And if you remember before, when we look at these arrows, the Y and the Z have that sort of X-axis plane. So that's what we want to do. And for now, just to demonstrate, I guess, a common problem and one that came up quite recently, which is a bit weird. It was like the day that I recorded this, but either way, a common problem is people just hook this in as you see it now. So you have the Y into the X and the Z into Y. And I'll just complete this node setup here, but then I'll show you, what the problem is and how to fix it. So we do need to get our texture 2D again. but we can just set this one to a reference, and then we can reference that original texture that we had. So this means, we don't have to use like multiple textures. And we can't just use the same one that we are using, because that is obviously using the Z world UVs, whereas we want to create a new one with X UVs. But either way, we're going to loop this again, but of course this time we're going to use the X mask that we made. And then we're just going to add these two together, and you can already see, I hope at least, that something looks a little bit wonky. And so let's just see what this looks like by reusing our register node there, because it's already hooked into our master area, so we'll just reroute that and then have a look. As you can see, we do have the X projection. Like, it's technically correct, but it's the wrong way around. It's, it's not going from the top to the bottom, it's going left and right. And the easy fix for that is to just swap it around. So Y into Y and Z into X, and that's it. You're done. And there we are. So that's all, that's all pretty good. If you rotate your objects around, you can see that, the raindrops are still trying to go down. If you rotate this, it goes that way. Pretty cool, I think. It's a nice effect. But you may have noticed we've got some, on more curved objects, things do get a little bit weird. You can see this, it's a very sort of peculiar 45-degree distortion, like almost as it kind of warps around. And we can do some things to control this, to mask it out. And so that's what we'll go and take a look at next. So if you come back to, the mask generator that we made, give ourselves a little bit more room. We're going to put down a subtract node, and then we'll just get a vector 1. Let me show you what happens here. As you can see, the more I subtract from this, the more this mask changes, so the white begins to become less. And we're using the white areas to determine where a texture is shown. So if you can see here, if I just commit that change. Oh yeah, I forgot about that. Yeah, we'd fix this with a saturation node. Bada bing, bada boom. Okay, there we go. So now you can see we still have the streaks going down the sides and the front, but it's not so much coming, like the side ones are not interfering in the front so much, and the front ones are not interfering in the side so much. So if you're only using like a cube to test this out on, these kind of issues can be hard to see, but it's a good idea to have a range of objects in your scene so you can see how different geometry reacts to it. And while we're here, I might as well show you, visually why I went with the vector 2 for the tiling amount for our rain streaks. And it's just so we have, a little bit more control, so you don't only just tile it uniformly. You can, if you want, make much longer streaks or much shorter streaks. I don't know why you would want shorter ones, but it's a choice that you have. So the functionality so far of the rain streaks is kind of done. We are going to be adding more, of course, but for the purpose of this node setup, it's complete. So I can just select all of these, and I'll press the C key just to comment it and give it a sensible name. We don't need to come back in here, like this is done. But the next thing we're going to move on to is the distortion. So we have the raindrops that come down, but we don't want them to just keep coming straight. We want them to kind of move about a bit. For that, we will need to distort the texture somehow. And the way that you normally do this, especially with refraction type things, is you would use like a normal map of like a noise texture. Ideally, it would be tiled so that you could change it. For the sake of this tutorial, I'm just going to use the inbuilt noise generator. I'll plug a UV into that, and then also a vector 1 just to control the scale of our noise. And now I'm going to use a normal from height node. This is pretty cool. I don't know if it's a new addition or if I just completely missed it in my previous tutorials, but I know about it now, and it kind of opens the door for some more cool stuff. But that's a whole other topic. Basically what this will do is it will allow us to take a black and white input, so not just like a texture, but anything that is black and white, and it will use Unity's inbuilt system to convert that into a normal map. And then what we want to do is put down a component mask, and we want to only use the X and the Y channels, because as far as the normal map is concerned, Z is blank information. X and Y just determines, the like the left and right, up and down orientation. There is no real forward. At least that's my understanding. Then we'll get a multiply node, and we'll stick a vector 1 on there, and this will control the power of that noise. So, you know, the stronger this amount will be, the more the texture is going to be distorted. So not to be confused with the scale that we have for the other vector one that's going into the noise generator. That just defines like how big this noise map will be. But the distort amount vector one will determine, you know, how much power basically to apply to our texture within the confines of that noise. So let's just make another register, call this distort, and slap it all in. And now we can just select everything, hit the C key, and yeah, we are done with this as well. But of course we still need to use it. So when I said before that we were done with the streaks and UVs thing, completely forgot that we are in fact not, because we still need to add our distortion onto it. Because if you think about the way that this works, it's that we need this distortion to affect the texture on like a UV level. So it's not an operation that you do to the texture after the fact. It's something that has to actually manipulate our texture's UVs. So we'll come over here and we'll make some more space, and we'll just grab everything up to the panner node. So on the left hand here we have our world space UVs, and then that's all hooking into, you know, the panner and our texture, which we are defining as those UV inputs. So this is where we want to just add in our distort. And that is as simple as just adding an add node and then using a get, and we'll just grab our distort reference and then just hook that in. And so now, I don't know if you can see or not, but even from the little reference we have over here, we can see that it's already beginning to squiggle up a bit. So if we take a look at what this looks like, depending of course on like the scale of the object and how it's laid out in terms of UVs, you're going to get different results. And this might be a bit confusing because we're of course using world space UVs, but we're not using world space UVs for our noise map. The noise map is still confined to a 0 to 1 UV space. So the raindrops are fine, you know, they are adhering to the world normals. But the noise map that we're using to distort them are not. So that's why you will get different results depending on the object's UVs, which is fine, you know, because this is all completely tweakable. You know, different materials can have different values. And yeah, I won't linger on this too much. We have all of the controls. You know, you can change the scale of the noise and you can change the amount that the streaks are distorted. So that's all good. Of course, up until this point, we've just been running all of this through the emission, which is fine. It's a good way to see this whole thing progress in a, you know, more visually easier to read manner. But just to move things along a bit, we're going to stick this into the smoothness slot now, because, you know, eventually that's where a part of it is going to be anyway, because we want this to be, you know, the wet rain. And we'll just come into our scene here and add a light just so we can, you know, see something a bit more morally, a bit more, see it more. Oh, English is late. Either way, you can see that there. And another reason for why I'm now taking us out of the emission is it's time to use that normal from height node, which we can use to turn our own rain into a normal map. Now, bearing in mind that you will almost certainly want some sort of multiply slider here to determine the power of this normal map, because you don't really want it going all the way up to a 1, because it can look a little bit kind of weird. So once you've set all that up, made your register, and then come over here and got that register and put it in the normals, we can see how that is actually looking on the mesh. Might be a little bit hard to tell. So if I actually just stop the time, you can see the difference it makes. And you can see, you know, when you get up close, there is that sort of really horrible banding. So I just tend to work with, you know, like a mid-range value, like a 0.5 or something. It works pretty nicely. Okay, so we still have one more thing left. You know, the obvious elephant in the room, I suppose, is those splotches. So let's just go ahead and we'll just start creating the whole setup for that now. And we're going to begin with a thing that I cannot pronounce. It's a Voronoi. I don't know. Maybe it has to be Voronoi. No idea. It's one of those things that you always read, but you never hear. This is going to be essential for those splotches, and it's where we will actually use the gradient that we're using in the B channel of our texture. I do want to point out, however, that even though Shader Graph has a Voronoi node, to my knowledge it does not have the ID output, which is unfortunately crucial to this effect. Now there are other ways to do what I'm about to do, but to my knowledge, if you're trying to do like a straight conversion of, you know, this node setup, for the splotches at least, the streaks should be fine, then you're going to struggle. Like, you're going to have to find a different way to do that in Shader Graph. Moving on, because obviously I'm just creating things on screen here and not talking about it. We have plugged in a UV coordinates node, a texture coordinates node, I suppose, into the UV slot for this Voronoi noise. And I want to stop saying that because I don't think I'm saying it right. And we have also put in a vector 1 to control the scale. So similar to the actual noise that we were using for the distortion. Now we do want this to constantly move, but we don't want it to pan or scroll. You know, we just want it to jitter about. So we will use that old setup of, you know, time multiplied by a vector 1. And we'll stick that into the angle of the node that I don't want to say again. So now we've got some movement happening here. Maybe a little too fast, but you know, it is what it is. I'll just now visually show you why shader graph can't do this. If I put the ID into this register, just as an example, we're not going to use this register, you'll see something that might look a bit familiar. These are UVs, basically. Now this is crucial because we're going to be using our gradient on our texture to affect these UVs, or at least work in tandem with them. That's crucial, and to my knowledge, this cannot be done in shader graph. I could be wrong, but you know, my attempt at least yielded that result. By all means, let me know if I'm wrong about that. Okay, so moving on again, we're going to get a step node, and I've already done this before, so I know the values. Our first one, the large one, is going to be the 0.1, and we'll create another one, small one, it's going to be a 0.02. Now, you don't have to be this specific. It could easily be like a 0.03 and a 0.2. You know, it doesn't really matter. So long as one is larger than the other and not too far apart, then you're okay. Now we'll multiply our largest step with the ID for the node that I don't want to pronounce. I hope that we're going to be done with that soon. And then hopefully you can see here how that step node is affecting these UVs. So what we're going to do is get a texture sample. And again, we'll turn this into a reference, and we'll just use the existing texture that we already have. And then we will grab a panner node, and we'll feed the UVs, these weird fragmented cellular UVs, and we will feed that into our panner UVs. And then just create a vector 1. This will be the speed of these splotches, so you know, the rate at which they live and die, basically. And then that can go straight into the UVs of our texture. And now, I know this looks just insane, like something out of the Matrix, but this is all going to come together. And the way that it comes together is by making use of that smaller step node that we have down there. I know it looks like we've completely forgotten about it, but we haven't. So we want to grab a multiply node, and we'll grab the green channel of our texture, because remember, the green is the gradient that we made. Oh, that was actually a bit of a coincidence. Green, G for gradient, wasn't on purpose. And we'll feed the step into that multiply that we've just made. And so now you can see here that we have these splotches that are appearing and then slowly fading away. And this is the magic behind why we have that gradient there, because the gradient was, if I could just have something on screen as a bit of a visual guide. It was white on the left and black on the right, meaning, you know, these UVs, this is how we're telling them to appear. They're going to just boom, like straight in from the left, and then fade out on the right. And we're able to do that on like an individual cell level because of that magical ID output on the Voronoi node. That is a lot of talking that probably didn't need to happen, but carrying on, we're going to just multiply this again by a vector 1. We'll turn this one into a slider. This will be our overall power, so you know, you might not want your splotches to be completely 1, so it's always good to have an option for power. And then, as usual, create a register, stick it in, and we can use that as a get. As a bit of a demonstration for the work that we've just done, we'll get that splotches and we'll put it into debug. When you put something into the debug in Amplify, it will like completely ignore whatever else you've got hooked in, which is, you know, it's a really nice way to test one thing without having to unhook a bunch of others. So, okay, there it is. There's quite a lot obviously happening to create this effect, but we're not using the world space mapping for this. We will use the world space mask that we created, but for the actual mapping, this is actually still just appearing based on the object's UVs. So you can see over on our truck, they're actually quite big because of the layout of the UVs of that. It's not a truck, is it? It's a bus, a vehicle, whatever it is. Whereas the cube, you know, each side of that cube is a 0 to 1 UV range. That's why it appears like a lot smaller. And at this point, just a little tip, I do like to keep my materials kind of clean, and so any property that I don't particularly need to have, I will turn them into constants. And so for the actual movement of the splotches here, I felt like I could change it on the material to a specific value. I think I went with 0.2. And I'm happy with that to just, remain consistent throughout any material that I create from this. So I can go back to my shader and I can select that node, give it the value of the 0.2, and then turn it into a constant. So now it's there forever, stuck, So I've been rambling on about that for a bit much. Obviously you have the controls for the speed and the scale, and that's it. Everything's hunky-dory. So we can move on, and we will now look into the masking. So we don't want this splotches appearing everywhere. If we just come back to our shader, give ourselves a little bit more room, all we're going to do is multiply our splotch result by the Y mask that we have. But there's a little catch here, which I could have corrected like immediately, but learning is just fun. So if you can see here, after we hook all that in, our Y mask is going through that absolute node. So this is on the top and the bottom. We're basically telling this texture where to exist, and we don't want to do that. Like, we only want this to be on the top. If you remember from the beginning of the video, we're actually just going to feed the Y component of the world normal straight into that register. And so now you can see, even from the little preview image, this is only going to affect the top. Like, it's not going to the bottom as well. So that's perfect, ideal, one might say. So we can give this a quick look, since we already have this fed into our debug. And as you can see, it's working pretty well. Obviously on the cube example, because our sides are so straight, we're not getting any of the splotches there, but any of geometry, like on this vehicle or the sphere, it looks as though the splotches are coming down on the sides. Technically, that's not the case. It's just the fact that the geometry is angled in such a way that the mask allows it to get through. And so even if you wanted this splotches to appear on these completely straight walls, all that means is we just need to do like the opposite operation as to what we did to the streaks. So for the streaks, we subtracted an amount, which created less space for the texture to appear. Whereas we want to create more space for the texture to appear, because we want it to come down on flat walls a bit, but we still don't want it to go all the way to the bottom. So we're just going to add, and we'll add the same amount as the subtract, just for easiness' sake. And so I'll just see what that looks like. And there we go. You see, so even on the cube, everything is hunky-dory. You can, if you want, mess around with that vector 1 that we're using to subtract the streaks and add onto the splotches, but just remember that, they are connected. So if you change one, it's going to change the other. You could always just make a new vector 1 if you wanted. That is entirely within your ability. So now comes the point where, you've tested all of your individual systems, I suppose, and it's time to combine everything together and then just try to find the issues, I guess. So we're going to place down a couple of gets, 2 to be precise. One will be our streaks and the other will be our splotches. And then we're just going to add them together, and for a good measure I would throw in a saturate as well. It's always good to try to clamp values down when you've been adding things together. And we'll stick this into another register, call it, combine or whatever, and then highlight everything, press C, turns it into a group. Pretty simple, I know, but not everything has to be complicated. Now if we take a look at this, so again, I'll change over the register that's in the debug so we can have a look at what's happening. And yeah, there we are. So I mean, if you ignore the scale differences between the vehicle and the cube, everything's pretty good. Obviously we need to tweak with the distortion amounts, the speeds, the tiling, but functionality wise it's looking pretty good. We have the splotches appearing on the top and all of the sides, and we have the streaks only appearing on the sides, so it's all pretty cool. If we were to just hook that straight into smoothness, you can see there, things are starting to look a bit more, I don't know, realistic, I suppose. There are certainly things that I could do to improve this, things that I would want to, but you've seen how long this tutorial is becoming already, like just expanding at this point is just unnecessary. Hopefully I've given you enough of a tool set for you to continue on your own though. So there is just a few minor things before we can call it a day here. I just wanted to show you, obviously you're probably going to be using this on your own models that have their own textures, their own normals, their own metallics and smoothness. So just in case there was any confusion, you can just grab the combine reference that we've made here, which is everything, the splotches and the streaks, and just add a texture or a vector 1, if you wanted a slider to control it, or if you have a texture. And that is pretty much it. One thing I don't show here is the normal map. In that if you have a normal map of your own that you want to blend with the normals of this, make sure you do use a normal blend node, because that will actually blend the normals properly instead of, I see a lot of people using lerps, which just basically, it weakens both of them by about half. It still kind of looks right, but I would say to try to use just a proper normal blend where you can. And the last thing, I think, at least, is you'll notice here as I'm putting this slider all the way to 1, we can still see our streaks, but those splotches are gone. They're just not there anymore. And of course, that's happening because we're using our splotches as a smoothness, and we're also putting up a slider to say, you know, smoothness equals 1. So if everything is at a value of 1, then we're not going to see the splotches on top. It's not like splotches are a value plus 1, like everything will just be 1. And this is just a minor mistake on my part in that I forgot to put the splotches into the normal setup that we'd made. So if you just come along to where we have that and just change the reference to the combine reference, and then everything is hunky-dory. Again, you know, it might look a little bit weird if the strength is at 1, but we do also have the ability to control the power of our splotches rather than also just, you know, bringing down the normals of everything. You can just bring down the power of those. So pretty handy. But yeah, I mean, that is it for this tutorial. I know it's been a bit of a long one, and it's been quite a while since I've done a long tutorial, but there was really no way to get through this quickly. I mean, there's probably a couple of ways to get through this quickly. You see all these people now with the 1-minute tutorials. They could probably do it, but I felt as though, you know, there's stuff that I have to explain. I should probably just ramble less, but it doesn't matter. It doesn't matter. It's over now. It's done. We've both been through it. So yeah, I mean, congratulations for making it all this way, if you did. I hope this tutorial has been of use. As usual, if you want the texture and the shader file and nodes and, you know, all of that good stuff, hop along to my Patreon. Again, I'd just like to mention that I am not going to be providing the model of the vehicle. That's not mine to give away, but the link is in the description if you wanted to grab it yourself. It is free. And one other thing that I don't think I've ever said in my entire YouTube career is the wrong word, YouTube whatever, is I do have a Twitter. If you wanted to follow me on it, that would be cool. I don't really post much there except for the videos that I make here, so in fact there's no point whatsoever in following me on Twitter. Yeah, okay, but that will be that, so thank you very much for watching, and yeah, I will see you in the next one.